We're going to be graphing r is equal to 4 cosine theta in this example. To do that, one of the ways that we can work with it by hand is to just make a table of values. This one's going to be a little more involved than the previous two, but we'll still be able to figure this out. Let's try when theta is 0. So we'll have 4 times the cosine of 0. Remember that the cosine of 0 is 1, so 4 times 1 is 4. If we want, we can actually plot that right now. The radius is 4 and theta is 0, or the angle is 0. We can pick any other points that we'd like. We could pick, for instance, pi over 6. So if we did pi over 6, we would have 4 times the cosine of pi over 6, which is equal to 4 times, and the cosine of pi over 6 is going to be root 3 over 2. So 4 times root 3 over 2 is 2 root 3. That's the exact value. And if you type that in your calculator, you're going to get about 3.4. So if I go an angle of pi over 6 and out 3.4, it's going to be about right in here, maybe, something like that. We can pick even more points. We've got pi over 4. And if you'd like to, you can type this in your calculator or figure it out on your own. This one's going to be 4 times the cosine of root 2 over 2, which is 2 root 2, or about 2.8. So you can follow along with the previous 2 points to find that value. So if I plot pi over 4, 2.8, that's going to be right about here. Continuing on, I've got pi over 3. Now the cosine of pi over 3 is 1/2, and 1/2 times 4 happens to be 2. So at pi over 3, my radius is 2. And then we can take a look and we can work with maybe pi over 2 here for this one. And pi over 2, the cosine of pi over 2 happens to be 0. And so 0 times 4 is 0 as well. So our radius is 0 for that one. If we continue on, we've got 2 pi over 3 next. Now the cosine of 2 pi over 3 is negative 1/2, and so negative 1/2 times 4 would be negative 2. So when I plot this point here, I don't actually want to go 2 pi over 3. I want to go in that opposite direction by 2 units. So I'm going to be down here. Once again, that's opposite of the direction that we would have gone, which would have been up here. So that point would not be on this graph because the radius is negative here. As it turns out, the rest of the points will line up just like you think they might. So they'll line up here. And if we draw the shape of this graph, we're going to draw the shape of this graph that looks just like this here. Okay. Now the last part of this, or even the first part, if you did the directions first here that are listed above on this set of notes, is we're going to try to change this into rectangular form. So what I'm going to do here is I'm going to multiply the right side by r and the left side by r. I'll wind up with r squared is equal to 4r cosine theta. We usually slide that r in between the 4 and the cosine. So r squared is x squared plus y squared. And then r cosine theta is x. So if I subtract 4x from each side, leave a little space here because I know what's coming next, then I'll wind up with that being equal to 0. And then what I can do is complete the square here by putting a plus 4 in. So we'll have to add a 4 here as well. So I'll wind up with x minus 2 squared plus y squared is equal to 4. Now in rectangular, what that means is this is going to be a circle, and the center is going to be right here at 2, 0. We want to do the opposite of the negative 2, and then the y value is 0. The radius is also 2. So what I'm going to do is I'm going to go from the center right 2, left 2, up 2, and down 2. And the center is actually not part of the circle. It's a nice point to use, but it's not actually part of that circle. And so what we're going to do here is we're going to try to draw that circle using those points that we've listed. And you can see here, although the scale is off a little bit in terms of length, that the shape that is produced is exactly the same because the equations are exactly the same, with the exception that we're describing them a little bit differently.